so what I plan to do is give a very general overview, because I think the range of audience over here is very, very diverse. There are many young and budding scientists who are looking for important research problems, as well as there are many established scientists in other disciplines who might be wondering what this topic means. But I assure you that all of us use cloud computing and virtualization in our daily life. So therefore, it is important to get to understand some aspects, some basic aspects of cloud computing and virtualization. And after I'm done, Sri Gopinath and Mrs. Pamela Kumar will elaborate on some more specific aspects of this problem. All right, so the traditional mode of computing has been, we have our personal devices, we have our desktops and laptops, and we have a Word document. That's probably one of the first things that people do, right? When they get they get to connect, read email, and if they have to compose something, use a Word document. But that is sitting on your machine, and it has to be updated from time to time and all that. And now we have actually moved towards more Google Docs and so on, where the software is actually sitting in the cloud somewhere, okay? And that way, you don't have to worry about updates, okay? Google and whatever other software you're using is going to be updated for you automatically. Okay. Same about storage. You can have photos on your camera, but pretty soon, you want to put it up somewhere so you can have your friends access it. And so essentially, we put them in the cloud, right? So the cloud, therefore, is the computing resources that are sort of up there in the internet somewhere, okay, which can be accessed by anybody from anywhere. Of course, you have to have permissions and so on. All right? So this is from a personal perspective. From an enterprise perspective, and let me take the example of a university, like SV University, where we are right now. But let me phrase the problem from my particular university, University of California, Davis. So we have a student information system, which any university has, where the registrar keeps track of which students are enrolled in which class, and then professors can go and give grades, and professors can have their own class websites, and students access them. So students, staff, professors, they're all accessing this particular website. Until like 4 years back, this website that we use in UC Davis called SmartSite used to be on premises. But the vendor that provides this facility has 50 other clients. And for them to maintain 50 different incarnations of the same software is hard. So it made sense for them to put their software in the cloud. So they put their SmartSite website in a data center in Arizona so that all of the 50 university campuses can have access to the most updated information, which is great, except there's one caveat. Now, students, staff, professors who are accessing this website, they're stomping over the internet over which they don't have any control. In case of University of California, we have our own research and education network called CENIC, and then there's other networks like AboveNet, Zayo, etc., which are under other people's control. And if they are underperforming, malfunctioning, then we suffer. So therefore, it is also very important to ensure that the health of the paths over which you stomp over to access your cloud computing resources is good. So today, that is of course not my topic today, but actually I have a startup company which is looking at how to actually understand the health of these paths which are in the public domain, and how to sort of work to around unhealthy situations and inform people in advance. All right, so from on-premises hardware, we have now moved into the cloud. And the cloud will have various resources. databases, server farms, firewalls, actually many network functions, like firewalls and parental control and traffic shaping. We can even virtualize them. I know I just used a jargon, virtualize, okay? What does that mean? Okay, so we'll get to that. All right, so what is definition of cloud computing? NIST is a standards body, National Institute of Science and Technology. So their definition of cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, namely networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So this actually works very well for various, particularly small businesses, because they need servers, but then if they have to buy some servers, it may be very expensive. Pretty soon they have to expand their computing resources, again, additional expense. So wouldn't it be great if they can just lease the appropriate amount of capacity from some service provider, cloud service provider, and that is what cloud computing therefore is. It provides flexibility. You want to do more with less. So actually you can lease resources from Amazon Cloud Services and so on, only as much as you need, and pay for as much as you use, okay? So this is really, really great. All right, so what is virtualization? So virtualization actually enables cloud computing. So traditionally, we have this physical hardware, some computing machine. But on this computing machine, we can actually create many virtual machines, VMs. And you might be using one of these VMs, maybe for your, when you spawn a Gmail service with Google, maybe one of these virtual machines is allocated to you. Maybe this one is allocated to me. Maybe this is allocated to somebody else. So on the same physical hardware, we can have many virtual machines. Maybe 10 virtual machines, maybe even more, okay? And an enabler for this virtualization and cloud computing is really Moore's law, where the number of transistors in the integrated circuit doubles approximately every 18 months to 2 years. And this has essentially created this, huge data centers where in each data center we have these servers and racks of servers which can have pools of CPU, memory pools, storage pools, etc. So we have different types of service models then in this cloud computing arena. So SaaS is software as a service, like Google Docs. Platform as a service is PaaS. So essentially, if you want to do large computing stuff, okay, Google Cloud Platform, Heroku, Salesforce, okay, these are other examples. And then infrastructure as a service, like Amazon Web Services, from which you can lease resources, lease more and more resources on an as-needed basis. So there are various cloud service providers, and the most famous among them, I guess from a US-centric perspective, I would imagine there are equivalent ones in India, and maybe Ms. Pamela Kumar will cover some of them. Amazon Web Services, Microsoft Azure, Google Cloud Platform, etc. Okay, so some of the important aspects to consider in this CSP Cloud Service Provider operations is PUE, which stands for Power Usage Efficiency, okay, and operational costs. Namely, one aspect is this VM migration, which means, I have a virtual machine, that's great. But sometimes I might actually need to move my virtual machine, which is really possible through our emerging networking paradigms, because it might be too congested to operate too many virtual machines in one data center. And a particular example could be, actually let me show you a migration of a virtual machine, okay? So let us say that there's some virtual machine that's operating in the East Coast, and let us say it is like 5 p.m. in the East Coast of the United States, and people are coming home and they want to watch Netflix, okay? So now Netflix has some data center in the East Coast, and pretty soon the load on this data center will increase a lot. And therefore, it might make sense for Netflix to move some of these jobs to places where people are still working, haven't come home, haven't turned on Netflix yet, and there's capacity lying around. So essentially, we can do virtual machine migration, okay, to perform load balancing. And this is one of the most important applications of virtual machines, virtualization, virtual machine migration. There's a company called VMware, which just specializes in just this kind of thing, okay? But we can actually use virtual machine migration for many other things, okay? So we have load balancing, which I just mentioned to you. How about energy efficiency? Maybe it is daylight somewhere, and we have a lot of solar energy. If we can use these renewable energy resources and get the job done without costing much, we also reduce our carbon footprint. As the day progresses and the sun is going to set, we might have to move our machines to some other places where there's still daylight. Same with wind, okay? And also, we have dynamic electricity pricing in many parts of the US, and I suppose in other parts of the world as well. So if it costs less in some part of the world right now to get a job done, might as well migrate to those places and get the job done for lower operational cost. There are seasonal aspects as well, okay? Right now it is, winter over here. It's summer in the southern hemisphere. Maybe they need a lot of energy for their air conditioning, and hence energy cost is high. Energy is not that abundant, but they can shove many of the jobs to the northern hemisphere where it is cool right now, okay? And this way we can try to, manage our energy needs. Disaster resiliency, okay? If I know that some hurricane is coming and some parts are risky and my infrastructure might get damaged, I might plan in advance and move my critical jobs over to less risky areas. I think there are a lot of opportunities for PhD level research on each of these topics. And then network function virtualization, virtual network function placement. Where should I place my firewalls? For a small business, it might be too expensive to actually have and maintain all of these network functions that they would like to use. So they might as well lease some of these functions from a service provider. Actually, many of the telecom service providers are trying to get their central offices to also work as some mini data centers, okay? CORD, central office re-architected as a data center. So we can exploit some or these sort of telco providers can provide some of these virtual network functions. And then actually to get a job done, you might have to go through several network functions, and then we call that a chain, a network function chain, okay? So here's an example of virtual network functions. There's also application in SDN that I didn't talk about, but I think these are a little too advanced topics, so maybe I shouldn't really get into that. And I said I should keep my talk general. So with that, I will stop here.